Deep beneath the Earth's crust, a hidden world pulses with energy. Here, in the planet's molten heart, rock exists not as a solid but as a viscous, superheated liquid, magma. This is the engine of our world, a force of immense creation and, at times, terrifying destruction. Tectonic plates, the very foundations of our continents, drift upon this fiery sea, their edges grinding against one another in a slow, inexorable dance. Along these boundaries, particularly in the vast volatile expanse known as the Ring of Fire, the pressure builds. It is a crucible of unimaginable power, where the Earth's inner turmoil seeks a path to the surface. Our story begins with Mount Ignis, a sentinel standing watch over a sleeping landscape. It appears peaceful, a majestic peak against the sky, but its tranquility is a facade. Below, a chamber of magma swells, growing larger and more volatile with each passing century. Gases trapped within the molten rock expand, pushing upwards, searching for any weakness in the rock above. The ground trembles with faint, almost imperceptible tremors, the first whispers of an impending cataclysm. The pressure is reaching its breaking point, a geological time bomb counting down to a moment of spectacular release. The air grows still. Animals, more attuned to the Earth's subtle warnings, become restless. The mountain is alive, breathing, and its exhalations carry the faint scent of sulfur. Soon, this slow breath will become a deafening roar. The coming eruption of Mount Ignis is not just an event, it is a manifestation of the planet's raw, untamable power. It is a reminder that the ground beneath our feet is not static, but is part of a dynamic, ever-changing system, a story written in fire and stone that continues to unfold before our very eyes. In 1815, on the island of Sumbawa in what is now Indonesia, Mount Tambora awoke from a long slumber. This was not merely an eruption, it was an explosion of planetary significance, the most powerful in recorded human history. The initial blast was heard more than 2,500 kilometers away, a sound so profound it was mistaken for cannon fire. A column of ash, gas, and pulverized rock was ejected into the heavens, reaching an altitude of over 40 kilometers, piercing the very stratosphere. It was a plume of darkness that would soon cast a shadow across the entire globe. The immediate devastation was absolute. Pyroclastic flows, avalanches of superheated gas and rock, swept down the mountain's flanks at speeds exceeding hundreds of kilometers per hour, incinerating everything in their path. Entire villages and kingdoms were wiped from existence in an instant, buried under meters of hot ash and pumice. The sea itself recoiled, then surged back in the form of devastating tsunamis that scoured the coastlines of nearby islands. For those who survived the initial blast, a new horror awaited, a world plunged into darkness and choked by falling ash. But Tambora's influence reached far beyond the shores of Indonesia. The immense volume of sulfur dioxide and ash injected into the stratosphere formed a veil, a global aerosol cloud that reflected sunlight back into space. The result was a dramatic worldwide drop in temperatures. 1816 became known as the year without a summer. Frosts and snow fell during June and July in North America and Europe. Crops failed on a massive scale, and widespread famine set in. This single volcanic event altered the world's climate, demonstrating with brutal clarity how a geological event in one corner of the world can have profound and lasting consequences for all of humanity. 68 years after Tambora, the same volatile region of the world produced another cataclysm. Between Java and Sumatra lay the island of Krakatoa. In August of 1883, after months of smaller, ominous activity, the volcano unleashed a series of 4 colossal explosions. The third of these was an event of almost unimaginable violence. It was, quite simply, the loudest sound ever recorded in modern history, a concussive blast that ruptured the eardrums of sailors 40 miles away and was clearly heard as a distant roar in Australia and on the island of Rodriguez, nearly 5,000 kilometers across the Indian Ocean. The force of the explosion was so great that it obliterated 2/3 of the island, collapsing the volcanic edifice into the sea. This collapse displaced a monumental volume of water, generating a series of tsunamis of terrifying proportions. Waves, some reaching heights of over 40 meters or 130 feet, crashed ashore on the coasts of Java and Sumatra. They swept inland with irresistible force, destroying hundreds of towns and villages and claiming more than 36,000 lives. The waves were so powerful their effects were registered by tide gauges as far away as the English Channel. the atmospheric effects were, once again, global. A vast plume of fine ash was propelled into the upper atmosphere, where it would remain for years. This ash circumnavigated the globe, producing spectacular, vividly colored sunsets that were noted worldwide. For months, the sun appeared blue or green through the haze, and the moon often had a distinct bluish ring around it. Artists of the era, including Edvard Munch, may have been inspired by these eerie Krakatoa-induced skies. The eruption was a stark lesson in the interconnectedness of Earth's systems, where a geological rupture can paint the sky on the other side of the planet. In the spring of 1902, the Caribbean island of Martinique was a place of tropical beauty, its skyline dominated by the verdant slopes of Mount Pelée. The bustling port city of Saint-Pierre, known as the Paris of the West Indies, sat at its base. For weeks, the volcano had shown signs of unrest, minor explosions, ash falls, and a permeating smell of sulfur. But the local authorities, fearing economic disruption and panic ahead of an election, downplayed the danger and discouraged evacuation. It was a decision that would seal the city's fate in a matter of moments. On the morning of May 8th, Mount Pelée did not erupt in the conventional vertical sense. Instead, the side of the volcanic dome collapsed, unleashing a pyroclastic flow, a dense, superheated cloud of gas, ash, and rock fragments. Hugging the ground, this incandescent avalanche raced down the mountainside directly towards Saint-Pierre at a speed of over 160 kilometers per hour. It was not lava, but a turbulent, gaseous hurricane with temperatures exceeding 1000 degrees Celsius. There was no time to run, no place to hide. The cloud of death enveloped Saint-Pierre in less than 2 minutes. It instantly ignited everything flammable, flattened stone walls, and boiled the water in the harbor. The city's 30,000 inhabitants perished almost instantly, their lungs seared by the superheated gas. Of the entire population of the city, there were only 2 known survivors, one of whom was a prisoner protected by the thick, poorly ventilated walls of his solitary confinement cell. The destruction of Saint-Pierre was a horrifying testament to the unique and deadly nature of pyroclastic flows, one of the most sudden and lethal of all volcanic hazards. In 79 AD, the Roman Empire was at its zenith, and the Bay of Naples was a thriving, sun-drenched resort for the Roman elite. Cities like Pompeii and Herculaneum flourished in the shadow of Mount Vesuvius, a mountain they regarded as a gentle, vine-covered giant. They were unaware that Vesuvius was a dormant but exceptionally dangerous volcano. On an August afternoon, their world was shattered. The mountain exploded with a force many times greater than an atomic bomb, blasting a column of gas, pumice and ash 15 kilometers into the sky. For hours, a rain of lightweight pumice stones fell on the city of Pompeii. It was terrifying, but not immediately lethal, allowing many inhabitants to flee. But as the eruption column grew heavier, it began to collapse under its own weight. A series of pyroclastic surges, more dilute and turbulent than the flows at Pelée, but just as deadly, swept down the volcano's slopes. The first surge buried the nearby city of Herculaneum, killing its residents instantly with intense thermal shock. Subsequent surges raced towards Pompeii, engulfing those who had remained behind. What followed was a slow burial. Meters of fine ash settled over the cities, perfectly preserving them. Buildings, frescoes, everyday objects, and even loaves of bread in ovens were frozen in time. When excavators rediscovered these cities in the 18th century, they found something extraordinary. The bodies of the victims had decomposed, leaving behind hollow voids in the hardened ash. By carefully pouring plaster into these cavities, archaeologists were able to create detailed, haunting casts of the people of Pompeii in their final moments. Vesuvius, in its act of destruction, had created an unparalleled time capsule of Roman life. The story of the Nevado del Ruiz volcano in Colombia in 1985 is a tragic lesson in a different kind of volcanic threat. The eruption itself was relatively small, a minor event by volcanological standards. On the night of November 13th, a series of small explosions occurred at the summit crater. This activity was enough to blast hot rock and gas onto the thick ice cap and glaciers that crowned the 5,300-meter peak. The intense heat caused a rapid, catastrophic melting of the ice and snow, a process that can unleash immense destructive power. The meltwater, mixed with loose rock soil and volcanic ash from the slopes, formed immense and fast-moving mud flows known as lahars. These were not simply muddy rivers, they were dense, concrete-like slurries, gathering speed and volume as they funneled down the mountain's steep ravines and river valleys. They traveled at speeds of up to 60 kilometers per hour, carrying boulders, trees, and debris with them, scouring the landscape with the force of a liquid bulldozer. The sound was a terrifying roar, heard long before the flow itself arrived. The town of Armero was built on a floodplain directly in the path of these historic lahar channels, a fact known to scientists who had warned of the danger. Tragically, due to a series of communication breakdowns and a lack of preparedness, the warnings never led to an effective evacuation. In the middle of the night, the lahars descended upon the sleeping town. They buried Armero in meters of thick, heavy mud, killing more than 20,000 of its residents. The Armero tragedy stands as a heartbreaking reminder that it is not always the eruption's fire that is deadliest, but sometimes it's water. So, in June of 1991, after centuries of dormancy, Mount Pinatubo in the Philippines awakened with spectacular and terrifying force. It would become the second largest eruption of the 20th century, an event whose effects would be felt across the entire planet. An international team of volcanologists had correctly forecast the eruption, leading to the timely evacuation of tens of thousands of people from the surrounding areas, a major success story in hazard mitigation. The eruption itself was immense, sending a colossal umbrella cloud of ash and gas more than 35 kilometers high into the stratosphere. The timing of the eruption coincided with the arrival of Typhoon Yunya, a potent storm that saturated the thick blankets of freshly fallen ash with torrential rain. This created a devastating secondary hazard, enormous widespread lahars that were far larger and more destructive than those at Nevado del Ruiz. For years after the main eruption, every rainy season would remobilize the ash, sending deadly mudflows cascading down river valleys, burying towns, and permanently altering the landscape. The eruption's aftermath was in many ways as destructive as the event itself. Beyond the Philippines, Pinatubo's greatest impact was on the global climate. The eruption injected roughly 20 million tons of sulfur dioxide into the stratosphere. This gas reacted with water to form a haze of sulfuric acid droplets that encircled the globe in just 3 weeks. This aerosol layer acted like a planetary sunshade, reflecting a portion of the sun's radiation back into space. As a result, average global temperatures dropped by approximately half a degree Celsius over the next 2 years. Pinatubo provided a powerful, real-world demonstration of how a single volcano can temporarily alter the Earth's climate system on a global scale. The stories of these colossal eruptions, from Tambora to Pinatubo, serve as powerful chronicles of our planet's restless nature. They are also markers of our own scientific journey. Today, a global network of seismometers, GPS stations and gas sensors keeps a constant vigil on the world's most dangerous volcanoes. Scientists can now read the subtle clues: the swelling of a mountain's flank, the changing chemistry of its gases, the pattern of tiny earthquakes that often precede an eruption. This ability to forecast has saved countless lives, as the successful evacuation at Pinatubo clearly demonstrated. Yet, for all our technological advancement, we must approach these titans with humility. Volcanoes remain fundamentally unpredictable forces of nature. We can make educated predictions about their behavior, but we cannot know with certainty the exact moment or the precise magnitude of their awakening. Each volcano has its own unique personality, its own complex plumbing system hidden deep within the Earth. Our knowledge is always growing, but the Earth will always hold its secrets, reminding us that we are inhabitants, not masters, of this dynamic world. These fiery mountains are not merely agents of destruction. They are a fundamental part of the planetary life cycle. Volcanic emissions help form our earliest atmosphere and oceans, and the rich, fertile soils they create have nurtured civilizations for millennia. They are a direct link to the immense heat and energy that power our world from within. They are both terrifying and beautiful, a raw display of the forces that have shaped our continents and our climate for billions of years. From destruction comes creation, and the story of volcanoes is the story of our ever-changing planet.